Okay everyone, it's time to start fractions, and I hope this can be the year that you realize that fractions don't have to be as bad as some of you have made them out to be. Right? Give them a chance. Don't give up before we even start. So we're going to take this nice and slow. We're going to do a couple days of basic skills, and then we'll get on to the adding, subtracting, multiplying, and dividing. So let's start with the real basics. What are these things we call fractions? Fractions are just a number. You could say they're two numbers, but that together makes one number that represents a part of a whole. So as you know, there's two parts to a fraction. There's the top part, which is called the numerator. I'll write that in there. There you go. The top one is the numerator. And you have a bottom number, which is, of course, called the denominator. Now, I know I've already revealed numerator, but it's probably easiest if we actually talk about denominator first. So the denominator, the bottom number here, tells you how many equal sized pieces make up a whole. So if our bottom number is 5, then that means if we were talking about something like, doesn't matter what shape I use, I could use squares, triangles, circles, whatever, I'm going to use a rectangle. So that bottom number, that 5, means that we are splitting this rectangle, this whole amount, into 5 equal pieces. Now that's hard, but give me a second here. Okay. I don't think it's perfect, but you get the idea. The 5 tells you that you've broken this whole amount, the whole rectangle, into 5, 1, 2, 3, 4, 5 pieces, and they have to be equal pieces. So that's what the bottom number tells you. It also kind of tells you the size, right? Because these are fifths, they're a certain size. If the bottom number was 2, you would have broken the whole only into 2 pieces. The pieces would be bigger. If the bottom number was 50, you would have broken the whole amount into 50 pieces. You'd have very, very, very skinny pieces. It would be very small. So the bottom number can also be thought of as how big the pieces are. What the top number is, the numerator, it's how many equal sized pieces you have or how many pieces you're interested in. So in this case, it says 4 out of 5. So the bottom number tells you we're breaking the whole into 5 pieces, and the top tells you we're interested in 1, 2, 3, 4 of those pieces. So this green amount right here is 4 out of 5. That's what basically a fraction is. So let's name some fractions here. So the first one, the whole amount is obviously the whole circle, and it's been split into 1, 2, 3, 4 equal pieces. In other words, our bottom number should be 4. If the bottom number is 4, we call them quarters, don't you? You can also call them fourths, but we often call it quarters. Now, how many are we actually interested in? Well, there's 2 ways you could look at this. You could look at it as 1, 2, 3. There's 3 of them that are shaded, so our fraction is 3 out of 4. I think that's probably what they intend you to do. But you could also think of it as, well, how much is not shaded? There's 1 piece that's not shaded, so you could also think of it as being 1 quarter not shaded. But I think we're supposed to go with the shaded part, so 3 quarters. All right, next one. The whole is this whole rectangular piece. How many equal pieces is it made up of? 1, 2, 3, 4, 5, 6, 7, 8. So these are 8s. There's 8 pieces total. How many are we actually interested in, or how many do we have, or how many are shaded? 3 out of 8. Or if you're interested in the non-shaded part, it's 5 out of 8, right? So it can depend what you're actually interested in here. But I think, again, we're interested in the shaded part. All right, here's a very strange whole, right? The whole is this whole shape that you can see here. Now that shape is made up of how many pieces? 1, 2, 3, 4, 5, 6, 7, 8, 9. So they've broken the whole shape into 9 different pieces. They're ninths. Each one of them is 1/9 of the whole. How many of them are we interested in? Well, let's look at the shaded ones again. 1, 2, 3, 4, 5. So this fraction is 5/9. All right, next important skill is taking your fractions and putting them in lowest terms. So for example, which fraction is this? Well, if I count it up, I can see they've taken the whole, which is a circle, and split it into 1, 2, 3, 4, 5, 6 pieces. So we're talking about 6 here. The bottom number should be 6. Now, how many of them are shaded? 1, 2, 3, 4. Okay, so my fraction is 4 out of 6. But we can put that in lowest terms, can't we? First of all, how come we can put it in lowest terms? Because I could redivide this thing. Rather than putting this into 6 equal pieces, I could make 3 equal pieces, couldn't I? I could do 1 piece here, So there's a piece that's not shaded. I could do one piece here. Here's a piece that is shaded. And I could do one piece here. Here's another piece that is shaded. So basically, if I look at it this way, I have 3 equal pieces, which means my bottom number would be 3. And I have 2 of them that are shaded and 1 not shaded. So if I'm interested in the shaded, I have 2 shaded out of 3. In other words, 2 over 3 must be exactly the same as 4 to 6. And it is, right? These two fractions are equal to each other. Now, why is this one 2 over 3 better? Because it's in lowest terms. Lowest terms is the simplest form of a fraction. It's when there's no number besides 1 that divides evenly into both the numerator and the denominator. Whoa, that's a mouthful. So what am I talking about there? What I'm saying is, if you look at this 4 over 6, there's something that goes into 4 and also goes into 6. What can you divide 4 by and also divide 6 by the same number? Well, yeah, you could divide them both by 1, but that doesn't make a difference. 4 divided by 1 is still 4, 6 divided by 1 is still 6. So that doesn't help. But you could also divide them both by 2. And if you divide top and bottom by 2, you get 4 divided by 2 is 2, and 6 divided by 2 is 3. And that's going to be your strategy to put things in lowest terms. You're going to try to find a number that you can divide the numerator and the denominator by. By the way, rather than calling it lowest terms, people also call it simplest form, and some people call it reducing. I do not like this. I will not use this word. Do you know why? Because reduce means to make smaller. And I get it. The numerator is smaller, the denominator is smaller. But the reason I don't like to use the word reduce is people think that the fraction is smaller. It's not. 4 6 and 2/3, remember, the exact same amount was shaded. 4 6 and 2/3 are the same size as each other. One's not smaller than the other. So that's why I do not like using the term reduced, and you won't hear me using it from now on. So for this one, you could say simplify these fractions or put the fractions in lowest terms. So what are we looking for? We're looking for a number that you can go into 4 and also goes into 12. You can divide those both by. And not 1 and not 0. Those aren't going to be useful. It has to be above 1. Well, how about 2? 2 would work. If I divide this by 2 and this by 2, what do I get? 4 divided by 2 is 2. 12 divided by 2 is 6. Great. Are we finished? No. You could actually do it again, right? 2 goes into both of these as well. So I could divide by 2, divide by 2. 2 divided by 2 is 1, sorry, and 6 divided by 2 is 3. That's our final answer. How could we have done this in one step rather than 2? Always try to divide by the biggest number possible. So rather than dividing by 2, which worked, it was fine, but if you had divided them both by 4, you could have gotten to the final answer faster. 4 divided by 4 is 1, 12 divided by 4 is 3, and we're good. Okay, 14 and 35, ooh, what can you divide those both by? Well, it might take a while. One thing you can do is look at your times table grid or something. Hopefully you'll be able to figure out you can divide them both by 7. So 14 divided by 7 is 2, and 35 divided by 7 is 5. And there's nothing else you can do there. That's in lowest terms. Okay, before we do these last two, look at these numbers. They're massive. How are we going to do this? Well, what we need to introduce you to is the divisibility rules. So what are these rules? These are rules that help you see if you can divide by 2 or 3 or 4 or whatever, and they help you do it in a very quick way. It doesn't tell you what the answer is. It just tells you whether it's possible or not. So for example, if I wanted to know whether this big number here, 3,456,546, I want to know whether it's divisible by 2. What's the only thing you have to worry about to see if the number is divisible by 2? All you need to worry about is whether the number is even or not. If it's an even number, in other words, if the last digit is even, or if you're confused by that, if the last digit is 0, 2, 4, 6, or 8, then it is divisible by 2. So how about the first one? Divisible by 2? Absolutely, because the last number is a 6. It's even. So for this one, yay, it is divisible by 2. How about this one here? The last number is a 1. That makes it odd, and that means not divisible by 2. Okay, how about 3? How do you figure out if something's divisible by 3? For 3, what you do is you add up all the digits and then see if that can be divided by 3. Now, you know what I mean by digits, right? This number right here, 2,346, that's one number. But how many digits make it up? 4 digits. The first digit's a 2, the second digit's a 3, the third digit's a 4, and the last digit's a 6. So what you do to see if it's divisible by 3 is you add up all those numbers. you actually do 2 plus 3 plus 4 plus 6. And if you do that, you get 2 plus 3 is 5, plus 4 is 9, plus 6 is 15. And then you ask yourself, is that number 15? Is that divisible by 3? And the answer is yes. So this is divisible by 3. The whole number is divisible by 3. By the way, if you're not sure if 15 is divisible by 3, first of all, shame on you. But you could do the same thing again. You could add again. 1 plus 5 equals 6. Is that divisible by 3? Yes, it is. So that works. Okay, let's try this one. We're going to go 2 plus 3 plus 6 plus 1 plus 1. 2 plus 3 is 5, plus 6 is 11, plus 1 is 12, plus 1 is 13. Then you just see if that's divisible by 3. Or if you want, go 1 plus 3 equals 4. Is that divisible by 3? Either way, no, they're not. So this is not divisible by 3. Okay, divisible by 4. If you want to know whether a big number is divisible by 4, all you actually have to do is just concentrate on the last two digits. You just look at the last two digits, and if they're divisible by 4, then the whole thing's divisible by 4. So in this first example, I look at 31. Can you divide 31 by 4 evenly? No, you can't. So this is not divisible by 4. How about this one? Can you divide 20 by 4? Yeah, 20 by 4 is 5. It goes in evenly. So this one is divisible by 4. Alright, next, divisible by 5. Well, you probably know this one. If something's divisible by 5, the last number has to either be a 5 or a 0. Okay? So all you have to do is look at the last number. If it's a 5, then yes, it's divisible by 5. And if the last number is a 0, like this one, then yes, it's divisible by 5. So both these numbers are divisible by 5. 6. Well, for a number to be divisible by 6, it has to be divisible by 2, and it also has to be divisible by 3. So you got to use both those rules. So remember, for 2, you look to see if the last number is even or not. And the last number in this case is even. Good. But that doesn't mean it's divisible by 6 yet. You still have to see if it's divisible by 3. So how do you do that? You add up the digits, 2 plus 3 plus 4 plus 6, and see if that's divisible by 3. 2 plus 3 is 5, plus 4 is 9, plus 6 is 15. Is 15 divisible by 3? Absolutely. So this one works. It's divisible by 2 and also by 3, so it's divisible by 6. Okay, let's try this one. If I was to do the 3's first, I would add up 3, 6, 9, 12, 15, so it is divisible by 3, but look at that last number. It's odd, so it's not divisible by 2. So because of that, it's not divisible by 6. So again, to be divisible by 6, it has to be divisible by 2 and 3, both of them. Alright, you might be wondering what happened to 7 and what happened to 8? Well, 8 is kind of like 4. You know with 4 it was look at the last two digits? Well, 8's look at the last three digits. It's not totally useful when you get some number like 872. Like, oh, I don't know. So I'm going to leave that one off. And 7's even worse. Sadly, there's not a great rule for 7. There is a rule. It takes a little bit of time. So let's go straight to 9. For 9, it's kind of like 3. You add up all the digits, but in this case, you're going to see if they're divisible by 9. So let's try. If we add together 3 plus 1 plus 4 plus 7 plus 3 plus 1, oh my gosh. 3 plus 1 is 4, plus another 4 is 8, plus 7 is 15, plus 3 is 18, plus 1 is 19. If you want, you could add again. 1 plus 9 is 10. Is 19 divided by 9? No. Is 10 divided by 9? No. So this one's definitely a no. Okay, let's try this one. 8 plus 8 plus 8 plus 1 plus 1 plus 1. 8 plus 8 plus 8, that's 3 eighths, is 24, 25, 26, 27. So you get 27. Is that divisible by 9? Yes. Or if you're not sure, add the 2 and the 7 together. Is 9 divisible by 9? Absolutely. So this big number here, 888,111, is divisible by 9. And the last one, 10, I'm sure you know this one. If the last number is 0, then it's divisible by 10. So this last one's a 5. It does not divisible by 10. And in this one, the last digit's 0, so this one is divisible by 10. Okay, let's try a couple numbers here. So we want to know what this is divisible by. So is it divisible by 2? Yes, it's even. How about 3? Well, we got to add them up. 3 plus 9 plus 7 plus 4 plus 0. 3 plus 9 is 12, plus 7 is 19, plus 4 is 23, plus 0 is still 23. Is that divisible by 3? No. So it's not divisible by 3. Okay, 4. We look at the last two digits, the 4 and the 0. Is 40 divisible by 4? Absolutely. So 4 works. How about 5? Yes, it ends in 0, so 5 works. How about 6? The only way 6 works is if 2 and 3 work, and 3 doesn't work, so no good. 7 and 8 we're skipping. How about 9? Only if 23 is divisible by 9, and it's not. And how about 10? Oh yeah, it ends with 0, so that works. So it's divisible by these 4 numbers. Okay, let's try this one. Is it divisible by 2? Yes, it ends with 0, so it's even. How about 3? Got to add it up. 5 plus 5 plus 4 plus 4 plus 0. 5 plus 5 is 10, plus 4 is 14, plus 4 is 18, plus 0 is still 18. Is that divisible by 3? It is. Okay, how about 4? Look at the last 2 numbers. Oh, it's 40 again. So, yes, it is divisible by 4. How about 5? Ends in 0, so it's divisible by 5. How about 6? Well, it's divisible by 2 and 3, so that means it's divisible by 6. How about 7 and 8? We're skipping. How about 9? Is 18 divisible by 9? It is, so 9 works too. And how about 10? Yeah, it ends in 0. Wow, look at every test. It passes every test that we learned. Love that number. Holy moly, that took a lot of time, didn't it? I'm sorry about this. I'm sorry this video is so long. We're almost done though. We just have these last 2 questions to answer right here. We got to put these 2 fractions, back to fractions now, put these in lowest terms. So now we have our divisibility rules, so maybe we can figure some stuff out. Well, here's something I realized. These both end in 0. So what does that mean it's divisible by? If it ends in 0, it's divisible by 5, but even better, it's divisible by 10. So let's divide them both by 10. 150 divided by 10, so you get 15 over 65. You can use a calculator for this, it's no problem. 15 over 65, look, they both end in 5, so that means you can divide them both by 5. 15 divided by 5 is 3. 65 divided by 5, you might need a calculator for that, it's 13. And that's it. There's nothing that goes into 3 and also 13, so that's the final answer. If you divided them both by 50, you could have done this in 1 step rather than taking the 2 steps we took. Alright, how about this one? 342 and 888. Wow, that looks hard. Well, we could start small. We could divide them both by 2 because they're both even, aren't they? So 342 divided by 2 is 171. And 888 divided by 2 is 444. So let's see what these add up to. If I add the top ones together, 1 plus 7 plus 1 is 9. And if I add the bottom ones, 4 plus 4 plus 4 is 12. So you can't divide them both by 9, but you could divide them both by 3. So that means both these numbers are divisible by 3. So let's do that. Let's divide them both by 3 and see what happens then. 171 by 3 is 57. And 444 by 3 is 148. Now, is there anything else that goes into both of these? Not 2, because this is odd. Not 3, because this one adds up to 13. Not 4, because of this one. 5, no. 6, no. 7, 8. Not sure, so we'd have to check 7 and 8, but no, that doesn't work. 9, no. 10, no. No, I think this is it. This is lowest terms right there. Alright. I'm sorry everyone, this has been a very long video, but I hope it's making sense, and if not, let me know. Don't worry, we're going to get through fractions okay this year. You'll do fine. Bye.